Hi, I'm Diana.
And my name's Kayla, and today we'll be teaching you the physics of lacrosse.
Let's go.
Okay. The field of play is 110 yards long and 60 yards wide. The goals are 6 feet by 6 feet, and the goal sits inside a circular crease measuring 18 feet in diameter. Newton's first law: an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by another force, like gravity.
When passing or throwing, we use our sticks as a leverage as a push and pull motion on the shaft of the stick.
Once in the air, the ball is a projectile, or any object on Earth that moves through the air and is acted upon by gravity and air resistance.
When you begin to pass the ball, you're putting the lacrosse ball in motion. Once it leaves the stick, it continues until acted upon a force, such as a receiver's stick or gravity bringing it down. This is a diagram of 3 different projectiles. In the first diagram, you see that the girl is passing at a 30-degree angle. This means the hang time is the least amount compared to the 60-degree angle, where it's the longest hang time. The 30-degree angle is the best for a short pass to a player, and the 45-degree angle and 60-degree angle is good used for a pass or a goalie clear. You might not realize, but lacrosse athletes automatically compensate for these variables, as if they are instinct. Notice when I pass the lacrosse ball, the angle is smaller. This is because my stick is lighter, so I am able to move it faster. Kayla's goalie stick is bigger and heavier and has more air drag, therefore slower, so she has to throw it at a much greater angle in order to compensate.
The further away we stand from each other, the more force is needed to get the ball the correct distance.
Now we will show you a short clip on centrifugal force. In the game, in order to keep possession, a player will cradle or move the ball from side to side.
In doing so, we use centrifugal force. Centrifugal force is a center-directed force that causes an object to move in a curved but sometimes circular path.
We use cradling, so when we run with the ball, it doesn't fall out. And when an opponent checks or hits our stick, the ball doesn't fall out. The lacrosse stick transmits the centrifugal force, pulling the lacrosse ball from a straight line path into a circular path.
Now we're going to show you the most important aspect of the game.
The celebration.
The physics of the celebration after a win lies in the collision.
The collision of an object clearly shows the conservation of momentum.
It also shows Newton's third law.
Every action has equal and opposite reactions, so if an object applies force to another object being acted upon, but it's the same force in just in the opposite direction. Now we're going to show you how it's done.
Yeah, go.
That's good.
That's fun.
Easily checkable.
Who's good?
How do we use this?
We're so smart.
Let's run out there.
Freaking!
That's why you need cleats.
You're right, I should put some cleats on.
Oh my god. Take 2.
Force that causes an object to move in a curved path. Okay. The field of play is 110 yards long and 60 yards wide. The goals are 6 feet by 6 feet. The goal sits.
Shoot, I just drew this goal backwards.
I don't think we'll know.
Too late.